Okay, here in this part of the chapter we want to find the amount of energy stored in a system of charges. The question is, why when you put two charges separated by some distance, is there some energy in this system? So let's try to look at a mechanical analogy. Let's take a mass m1 and attach a spring to it, an uncompressed spring, and then bring a mass m2 and attach it to the other side of the spring. Now let's push mass m2 to the left with an external force until the mass m2 is pushed to a certain distance where the spring is compressed now. Now you can imagine that there's some energy stored here in this configuration. Why do you imagine there's some energy stored in this configuration? Because if you let go of these two masses, what will happen? The masses will start to gain speed and they'll start to go to the right. The mass m2 will go to the right, mass m1 will go to the left. So that means, remember that the total energy of the system has to remain constant. That means initially there must have been some energy there called potential energy stored in the spring, and then when you let go of the masses, the energy was converted to kinetic energy. So there must have been some energy there called potential energy of the spring. Well, the same thing you can think about for charges. Let's say you have a fixed charge Q1 and a movable charge Q2. And you bring an external agent and you move charge Q2 closer and closer to Q1. They're both positive charges. They don't want to be together. So you have to really force them to go together. So when you bring Q2 within a certain distance of Q1, how come there's some energy stored in this configuration? Because what will happen if you let go of these two charges, let go of both of them? Then they're going to start to gain speed. One of them will go to the left, one will go to the right. So that means they gain kinetic energy. Remember, the total energy of the whole system has to remain constant. So if the system is gaining kinetic energy, that means there must be something that's becoming less. And in this case, it's electric potential energy. So there is something called electric potential energy that exists for these two charges, and this is what we want to try to calculate.